What's up to you all, matriculants? This is your favorite show, Learn Extra Live with me, AB. We're here to rock it also on this term. I hope you enjoyed your holidays. It is the beginning of a new term, so you should be refreshed. I hope you enjoyed your holidays, doing some studying, not playing because there's no time, mindsetters. Otherwise, I'm joined by Mr. Sihle. Sihle kunjani mfethu?
Ngikrende mfethu njani?
Nami ngishaphi mpela. Akho ngxaki tu. Kuthiwa ixesha liqhatywe yinja masikhawuleze sichaphazise siye phambili.
Blah, blah, blah.
You can hear me. How are your holidays?
Not too bad, but we're...
Not too bad.
Yeah, okay, a little bit bad because I was working.
Okay, that's not bad, man. That's what we need to do, man. No work, no pay.
No pay, no work, yeah.
Exactly. But otherwise, what are we doing today?
We're doing maths. Oh, okay. We're doing some trigonometry. Before I can tell you what we're doing, I just want to greet all the matriculants, boys, girls, and others. We're doing trigonometry today, compound angle identities and double angle identities. Sure.
Awesome, Mr. Mindset as well. Let me also set these parameters and tell you what to do today. Go to facebook.com/learnextra, like the page, share the page with everybody, your friends, your classmates. Tell them to like our page because that's where we learn more and learn extra. On the page, you can send your questions. You can also help other mindsetters because that's the spirit that we like mindsetters. Otherwise, you can also visit our help desk, which is an app that is also on Facebook. I'll share the link later on. Follow us on Twitter @LearnExtra. To get your notes, it's simple now. We have a new innovation whereby there are two ways. You can view the notes directly or download the notes directly just to help everyone. So whatever Sihle is going over, you can also have it, view it on your cell phone or view it on any other device or application. So we're here to help you, mindsetters. But for now, let's do this.
Sure, Fetsu.
Sure.
Today we're looking at your trigonometry, but we'll start with the revision of your grade 11. Now, guys, remember the time is running. It's running, guys. We approaching exams, and we need to see you in future driving your cars, buying houses of the money that you can't even call, which is maybe, for instance, 939,000, 3,000. And 60, close to 1 billion. Okay, all right, guys, so I'm going to be doing the trigonometry grade 11 revision and introducing you to compound angle identities, which is what you did in grade 11, and your double angle identities, which is this year, right? So, but before that, I would like you to take your challenge question here. It says it is given that P is cos alpha plus sine alpha, and Q is cos alpha minus sine alpha. Simplify P divided by 2Q minus Q divided by 2P to 1 trig ratio. So while we're doing your problems and stuff, but you're doing also your challenge question.
Thank you so much. And the challenge question is on Facebook, mindsetters. Make sure that you give it a try. Don't say it's too difficult without even trying it. So make sure that you try it out, and we'll see the right answer later on the show.
Hey, tada. And back to business, guys. I just want to go through your revision. We're looking at your grade 10 and then moving on to grade 11 before we get to the grade 12 one. But we'll be quick on this one because you've done it before. Say, for instance, I've got this triangle here, right? This is your Cartesian plane. You've got your y, x, and if I put a point there, this point is going to have your x and y coordinate. And if I join from that to the origin, so I've got OP and have my right angle triangle, which looks like this one. So I've got a theta there. Then this is your y, and that is your x, and this is your r. Now remember, this is your adjacent, and then this is your opposite, and then that's your hypotenuse. Now, I think most of you are using the soccer 2 to remember your trig identities. So soccer TOA. And your soccer 2, you've got S, C, and T. Your sine equals to opposite over hypotenuse, which is y over r. And then your cos is adjacent over hypotenuse, which is x over r, and your tan equals to opposite over adjacent. But when you get older, and some people when they, I'm not going to say this live, but they just saying signs of happiness comes after having tons of alcohol, but when you're done with your schoolwork. So this is your y, this is x, and this is r. This is your hypotenuse, and then this is your adjacent, and that's your opposite. Now, as we have said, your sine theta will be your opposite over hypotenuse, which is your y divided by r, and your cos theta is your adjacent over hypotenuse, which is your x divided by r, and your tan theta will be your opposite over adjacent. This is y divided by r. This is y divided by x, and that is your basic trig identities from your grade 10. But today we're looking at your compound angle identities. And your compound angle identities, the easy way to look at your compound angle identities, if I've got cos bracket x minus y, this gives, now remember in your caps, you don't need to prove your compound angle identities, but you need to know when to apply them. It is there in your formula sheet, but how do you remember them? If you've got a cos, this is cos, so it means I'm going to have cos, cos, and the different sign from the given information, and sine, sine. So in other words, I will have cos x, cos y, and I look at the sign, it is a minus, change that sign to a plus, sine x, sine y. Now the next one, which is the same, it's x plus y, then this is, now watch, it's still cos, so it's going to be cos x, cos y, minus, because my sign here, it's a plus, so minus sine x, sine of y. Now we're moving on to sine, so your sine will be, if you've got sine x minus y, is, now to remember your sine compound angle identity, it's going to be your sine cos, cos sine, right? So it's going to be sine of the first angle, which is x, cos of the second angle, and the sine stays as it is, which is a minus in this case, and you get your cos of the first angle, and then sine of the second angle, which is a y. Now the next one would be your sine bracket x plus y, that is your sine x, cos of y. The sine stays as it is, so it's a plus cos x, sine of y. Now let's just remind ourselves, just for the last time, if you're given cos, bracket say x minus y, it's going to be cos, cos, the sign change, the given sign, and then sine, sine. But if you're given sine, bracket x minus y, for instance, so it's going to be sine of the first angle, cos of the second angle, the sign stays as it is. If it was a minus, then it's going to stay a minus, and then cos of the first angle, sine of the second angle. Right, I hope you've got that one. Right, and then now, next, your double angle identities, which is your grade 12 stuff, it is derived from your grade 11, your compound angle identities, okay? So the first one, if I give you sine 2x, then remember we had sine of x plus y, and we said this gives us sine of x cos of y plus cos of x sine of y. Now, I'm taking the y out, I'm bringing in x. So this is sine of x plus x, which gives us sine of x cos, take out the y, it's x now, plus cos of x sine of x. Now these two are like terms. So you add the two, you get your identity, which is 2 sine x cos x. So in other words, what I'm trying to say here is that your double angle identities, they derived from your compound angle identities. So your sine 2x is 2 sine of x cos x. And our next one will be your cos 2x, which gives us cos squared x minus sine squared x. Now you've got three options here because you know the mother function for your sine squared x plus cos squared x, that it gives us 1. That's what we did in grade 11. So if I make cos the subject of the formula, then cos squared x will be 1 minus sine squared x. So if you sub in the 1 minus sine squared x, you end up with the 1 minus 2 sine squared x. So cos 2x can be written as 1 minus 2 sine squared x, or 2 cos squared x minus 1 if you make sine the subject of the formula, because sine will be 1 minus cos squared x. Are they saying I'm slow, fast, average, or are they quiet?
Good.
Thank you. Now, it was just a quick revision there, guys. Now, let's get to the problems. Right? As we said, we're just going to do some revision, your grade 11 revision. So the first question is, simplify without using a calculator, all right, showing all your working, okay? So now, remember, guys, some of you, I think most of the schools, you guys are using your Casio, or what's the other calculator?
Sharp.
Some Sharp, yeah. So of which you can get your special angles in those calculators. But if you don't have that, like us, when we did our metric, we use our indigenous calculators and stuff. But we had a triangle that helped us to remember our special angles. Say, for instance, I've got a 60 there, then that's root 3, that's a 1, sorry. We've got a 2 there, 1, so that's 30. So in other words, if I give you cos of 60 degrees, that will be your adjacent over hypotenuse, then that is 1 over 2. And if you have this calculator, you don't have, someone just, okay, you don't have that, okay. So you've got cos of 60, and then your calculator gives you the answer for your special angle. So when cos, if you calculate cos 60, then you get a half. All right? So now, let's just look at this problem. Tan 60, 60 is a special angle, right? And we know that tan is opposite over adjacent. So that will be your y divided by x. So in this case, we're looking at 60. So tan will be y divided by x. So you've got your root 3 divided by 1, which is just root 3. Okay? So we're done with the first bit. Now we're moving on to your cos 240. Now with your reduction formula, you've got your cos of 180 degrees plus now a special angle here, which is going to be 60. Multiplied by sine of 360 minus 50 degrees. Now remember, if you don't get a special angle, it means that there's going to be, say for instance, this one you get sine 50, so there's going to be a sine 50 at the bottom that's going to be chopped by the top, that's going to divide, sine 50 is going to divide the sine 50 at the bottom, okay? Right, now we move on. This is 270. 270 is a special angle as well. So you've got sine 270. You can draw a graph here of sine. This is a graph of sine, so that's 90, 180, 270, and the y value is a minus. Or you just press your calculator, sine of 270, you get a minus 1, right? Times the cos 220. So this will be your cos of 180 degrees plus 40 multiplied by your sine of, this is 360 minus 60. All right? Now, so we're done with the first bit. Next part. Now, we look at our quadrant, 180 degrees plus. Which quadrant is that? If I can just write it here, this is all students take coffee if they're not in a hurry to go to school. So in the first quadrant, all the trig ratios are positive. In the second quadrant, it's sine. And in the third quadrant, it's tan. And In the fourth quadrant, it's cos, and the rest is negative. So now you're looking at 180 degrees plus. 180 degrees plus is a third quadrant where tan is positive and the rest is negative. So it means that we're going to have root 3 times negative cos of 60 degrees times 360 minus, remember from grade 11, 360 minus is your fourth quadrant, and in your fourth quadrant it's only cos that is positive, so it means that our sign is negative, so you get negative sine of 50, all divided by a minus 1 times 180 plus is the third quadrant, which is the tan quadrant, and so it means that cos is negative, so you get negative cos of 40 degrees times 360 minus is the fourth quadrant, sine is negative, so you get negative sine 60. We are going to continue after the break, I think.
Awesome. I like that. Mindsetters, keep your questions coming, and later on we'll treat them. And do check out the challenge question on our Facebook page. See you after this break. Welcome back, matriculants. Now, in the spirit of giving, as Mindset Learn Extra, we love giving. So do check out next week. Sihle mentioned something earlier on about Casio calculators. So next week, we're having an awesome competition. I don't know what's in store, so it's a big surprise. Do check out that competition. It's probably sponsored by Casio, so make sure that you do check it out. I don't know. Maybe it's going to be calculators. Maybe. I don't know, but it's something good that is coming. We love giving. And do keep your questions coming. On Facebook, I did see some of the questions people were asking about the reduction formula. We've got all of that covered. Do follow us on Twitter also at LearnExtra. Back to you, Sihle.
Yeah, thank you very much. I'm glad you mentioned. Do follow us on Twitter. We're right behind you guys. Right, so I'm going to finish the problem, and I'm going to put it to you that we've got your reduction formula. I'm just going to explain a bit slow on reduction formula, but I'm just going to finish the problem here, and then we look at that. So now I have here with the signs negative times negative, which gives me a positive, and the bottom part, your denominator, you've got a minus times a minus times a minus, you get a minus. Positive divided by minus, it gives us a negative. So I've got negative root 3 times cos of 60 with our special angles. Cos 60 will be x divided by r, which is a half. So I've got that multiplied by a half times. Now, guys, very important. If you look at your, this is sine of 50 degrees, which is the same as sine of 90 degrees minus 40. Okay? Because 90 minus 40, it's 50. Now, remember, with your 90 degrees and 270, your co-ratios, your sine changes to cos and cos changes to sine. So this will be your cos of 40 degrees. Now, if you have a cos of 40 degrees here, and there is a cos of 40 degrees, so the cos 40 divides the cos 40. Okay? So that will be times a 1, all divided by, now I'm left with the sine 60. Now the sine 60, if you press your calculator, you'll get the square root 3 divided by 2 according to my right angle triangle there. So I get the square root of 3 divided by 2. All right? Now, you multiply numerator by numerator and denominator by denominator. So you've got a root 3 times a 1 divided by 1 times 2, which is root 3 divided by 2, all divided by root 3 divided by 2, which gives us a minus 1. Okay, so your final answer is minus 1. And the easy way out, if you want to check if you're doing the correct thing or not, take your natural display, type this thing in as it is, or if I can just spoon. So you put it as it is, press your equal sign, and then at the end of the day, you look at your answer, it's a minus 1. So you do everything that you were told at school, and your answer should be a negative 1. Now, I just want to spend 2 minutes and explaining your reduction formula. This was your grade 11. Now remember, this is your Cartesian plane. You've got a node here, 0 degrees and 360. And these angles, this first triangle, this first quadrant, you've got angles between 0 and 90, right? So you acute angles. And then I've got 180 here, I've got 270. And we're saying all the trig ratios are positive in the first quadrant, and sine is positive in the second quadrant and its reciprocal, which is a cosec. And in the third quadrant, you've got your tan, which is positive, and your cos. Now remember, in your first quadrant, I've got 0 degrees, 1, 2, 3, up to 90. So it can be 0 plus an angle, or 90 degrees minus an angle. In your second quadrant, I've got angles more than 90, but less than 180. So that will be your 90 plus and 180 degrees minus. In your third quadrant, I've got 180 degrees plus and 270 degrees minus. Fourth quadrant, I've got 270, up to 360. So I've got 270 degrees plus and 360 degrees minus. And remember, when you're going up, you've got positive angles, right? Positive theta. And then in the fourth quadrant, going that direction, you've got minus. Now, as we were doing this problem, I think that's where some people got lost, of the cos of 180 plus 60. Now, guys, we have cos of 180 degrees plus 60, all right? Now, 180 plus, we're going to look at the quadrant. Which quadrant is 180 degrees plus? Then this is the quadrant where tan is positive and the rest is negative. What am I given? I'm given cos. So it means that in that quadrant, it's negative. That's where we got that negative cos of 60. Okay, I hope that helps. Okay, now we're moving on. Abram, any questions?
We can take them later on.
All right. Now, we've got question 2. Consider the identity. You've got sine A divided by 1 plus cos A plus 1 plus cos A divided by sine A equals to 2 divided by sine A. Prove it, right? So you need to prove this identity. Now, remember, when you're proving identities, guys, from grade 11, you're taking the complicated side. You're trying by all means to make it the same or similar to the one that's simple, all right? So you can either take the left-hand side or the right-hand side, depending how complicated that side is. And remember, if you take, say, for instance, your left-hand side, and you simplify, and it does not get to as simplified as you want it to be, you also take the right-hand side. And as long as at the end of the day they're the same, then you can say, therefore, the identity is true. Now, we're looking at the left-hand side here, right? Our left-hand side, we're dealing with fractions, okay? Now, when we deal with fractions, we look for our LCD, not your televisions at home, but your lowest common denominator, right? The LCD here is sine A bracket 1 plus cos A. All right? Now, remember what you do with the LCD. You say your LCD divided by that denominator that you have there, and the easy way out is to close the one that you have. So, valaloko nako 1 plus cos A. So, I've got 1 plus cos A, 1 plus. So, and here there's things, those are very sensitive. So, you've got cos of A. So, now you're left with your sine A times the sine A, you get your sine squared A plus this plus here. Now, the sine A into sine A bracket 1 plus cos A, the sine A divides the sine A, you're left with the 1 plus cos A, which is going to multiply the numerator, and it's going to be 1 plus cos of A, and that is squared. Right? So now, the next part, I'm going to simplify the 1 plus cos A all squared. What does that mean? I've got the 1 plus cos A times the 1 plus cos A. And remember, if you've got x plus y, bracket x plus y, you get x squared plus 2xy plus y squared. Same thing. So you've got here sine squared A plus 1 by 1, it's 1, plus 1 times cos A is cos A, multiplied by the 2, so you get 2 cos A, plus the last part, cos A times cos A, you get cos squared A. All right? Now, this is all divided by sine A bracket 1 plus cos A. All right? Now, you go back to your numerator and you check if you've got any like terms. Now, remember your identities. Before you go to an exam, make sure that you know all your identities. And in this case, I have a sine squared A plus a cos squared A, which is one of our first squared identities. So sine squared A plus cos squared A gives us 1. So I've got sine squared A plus cos squared A. That gives us 1. So now you've got a 1 plus this 1, which gives us 2. So we've got 2 plus 2 cos of A, all divided by sine of A, bracket 1 plus cos A. All right, now moving on, we have, now there's a 2 here, there's a 2 there, and there's an operation sign between the terms, which is a plus. I can now take out a common factor of 2. So I've got a 2 bracket 1 plus cos A, all divided by sine A, bracket 1 plus cos of A. All right? Now, the 1 plus cos A divides the 1 plus cos A. I'm left with the 2 divided by sine A, which is the same as what I'm given the right-hand side. And you conclude by saying, therefore, the identity is true. The left-hand side is now the same as your right-hand side. So the identity is true, right? So I hope that helps. Are they following? Or?
Yeah, they are.
Right? Now, so the next part says, on the very same question, give all values of A from 0 degrees to 360 for which it is undefined. Okay? So now, when do you get an undefined solution? Remember, when you divide by 0, then that is going to be undefined, right? So you're not allowed to divide by 0 because we get a very huge number. We'll explain that later. Right, so I've got the denominators here. I've got the 1 plus cos A, the sine A, which was our LCD. So when 1 plus cos A and the sine A, it's equals to 0, right? So in other words, when I have sine A equals to 0, or when I have cos A equals to -1. Now, this one is straightforward because you can just draw your graph here, the graph of sine, and we're saying from 0 degrees to 360. So from 0 to 360, so there is a 90, 180, 270, and 360. Now, let's look at where our y values is 0. So I've got sine A, y is 0 there, 0 there, and 0 there. So where you have your x-intercepts. So in other words, I have when A is 0, or when A is 180 degrees, or when A is 360, then this will be undefined. And when we look at this graph here, the graph, of course, the one that you did in grade 10 and 11, so this is your 90, 180, 270, and 360. Now this is your -1 and 1. So where is x 180? Right? When x equals to 180, our y is -1. So we conclude by saying, now where is cos A equals to -1, from 0 to 360 degrees, it's when x is 180. So you've got your 3 solutions there. When A is 0, 180, and 360. Okay? Right. Now, moving on, if you're still following, right? So, given that sine 23 is G, okay? Express the following in terms of G, right? This is what they normally do when they set in these papers. They give you, like, you know that sine is y divided by r and your tan is y divided by x and what have you. You must try and make sure that you've got your x, y, and r. So I'll suggest you draw a rough right angle triangle. So with this sine of 23, now this is, if we can have the sine 23 equals to g, we know that sine is y divided by r, so the denominator here should be 1. So you've got your G and 1. This is 23. Okay? And then, so we need to work out this part, right? Now, this is a right angle triangle. We did this in grade 8, 9, and up. So your x squared plus y squared equals to r squared. You work that one out, so the bigger one minus smaller one, so you get the square root of 1 minus g squared, because if you have x squared plus y squared equals to r squared, and then you make your x the subject, right? So now you've got that. Now, let's work the first problem out. You have sine of 203. Sine of 203 will be, now mind you, you have to try by all means to get that 23 in there. So this will be 180 degrees plus 23 degrees. And remember the reduction formula, 180 plus is the third quadrant, which is your tan quadrant, and tan is positive, so it means the rest is negative. So you get negative sine of 23. But this was a given information. Sine 23 is given, it's g, so you get minus g for this one, right? Now, you come to cos of 23. You were given this triangle. This is 23, and then this is g and 1. We said this is 1 minus g squared. Now, remember, cos is x divided by r. So x in this case is going to be square root of 1 minus g squared divided by 1, which leaves us with the square root of 1 minus g squared. Okay? Hope you're still listening and following. And see you. Okay? Now,
on that note, I think we can take a net break and then come back to the last question.
Are you sure?
Yeah.
No problem, no problem.
Cool.
No
Mind
rush.
tutors, keep your questions coming on facebook.com/learnextra. And remember, we also have our help desk application on Facebook. I'll share the link right now. In the meantime, do the challenge question. We'll see you after this break. Welcome back, awesome mindsetters. Now, I told you earlier on that in the spirit of giving, we as Mindset Learn Extra, we're going to be having a competition that's running from next week. So keep your eyes peeled on your screens and on facebook.com/Learn Extra for that awesome competition, probably sponsored by KSU. But for now, keep your questions coming also. And Mr. Sithe, it's time for the challenge question. I see so many answers on the page.
Different ones or the same ones?
Different ones.
Oh, Jehovah. Can you just give me a few?
Okay. While I give you the few, okay, most of them are saying the answer, tell him it is 2 sine alpha. That's what they're saying. Some are saying it's 10-2. Yeah. And this is very easy. Okay, but no answer. The answer is 0. My last step is sine 2, 0, minus 1, 10-2, most of them.
Okay.
Yeah.
All right. Now, guys, can we just look at your challenge question, just because of time? So we're going to be looking at your challenge question, and then we go back to the problems and looking at your questions from your the Facebook page. All right? So now, if we check here, it's given that P is cos alpha plus sine alpha, and your Q is cos alpha minus sine alpha. You need to simplify that to one trig ratio. It can be sine something, cos something, or tan something at the end of the day, right? So you're going a bit slow on this one, right? So you've got, the P here, it's given cos alpha plus sine alpha. So I have sine alpha plus cos alpha, all divided by 2, and your Q in this case is cos alpha minus sine alpha. Cos alpha minus sine alpha. Minus, that minus from your question. And your Q is cos alpha minus sine alpha, all divided by your 2. And the P is your sine alpha plus cos alpha. Okay? So you've got cos alpha. This is P is cos alpha plus sine alpha, and we substituted correctly. That's P, and then you have your Q cos alpha minus sine alpha, your Q is cos alpha minus sine alpha, and your P is as cos alpha plus sine alpha. Okay. Now, we haven't done anything. We just substituted the values that are given, the P and the Q. Now, next, because I'm looking at the fractions here, I will need to take out the LCD. And our LCD, in this case, will be your 2 bracket cos alpha minus sine alpha bracket cos alpha plus sine alpha. Now, like the other problem that we've done, so we're saying the LCD divided by this denominator that's given there. Now, you've got your 2 cos alpha minus sine alpha dividing the 2 cos alpha minus sine alpha. So now what I'm left with is this part. That's going to multiply our numerator. And our numerator in this case is sine alpha plus cos alpha. Okay? So, and that gives us your cos alpha plus sine alpha squared, because this is the same as that. Okay? Now, minus the 2 sine alpha plus cos alpha into that, the 2 divides the 2, and the cos alpha plus sine alpha divides the cos alpha plus sine alpha. I am left with this part, which is going to multiply the numerator here, which is your cos alpha minus sine alpha. If you multiply x by x, you get x squared. And in this case, you've got cos alpha minus sine alpha times the cos alpha minus sine alpha. You get the same thing, which is cos alpha minus sine alpha squared. So I have the cos alpha minus sine alpha, and that is squared. Okay. Now, I hope you all following. Okay. Now, guys, remember, if I have the x plus y all squared, what does that mean? I've got the x plus y times the x plus y, which gives us the x squared plus 2xy plus y squared, which is the same thing here. I have cos alpha times cos alpha, which gives cos squared alpha. All right? Now remember, in grade 10, we're saying cos alpha times sine alpha. You get sine alpha cos alpha times 2, because you've got 2 lots of cos alpha plus sine alpha. So I get plus 2 sine alpha cos alpha. Plus, your last term is sine alpha times sine alpha, which is sine squared alpha. And minus. Now, remember, you need to put a bracket there, because that minus is going to affect all the signs that are going to be in that bracket. Okay? Remember the BODMAS rule, or BOMDAS. Right, so you've got your cos alpha times cos alpha, that is cos squared alpha, minus the cos alpha times the sine alpha is cos alpha sine alpha times 2. You get 2 sine alpha cos alpha. Then the last term will be your plus sine squared alpha. Okay, right, this is all divided by your 2. Now, watch, very important. I've got my denominator, and now, guys, remember, if I have x minus y, bracket x plus y. Now, this is from your difference of 2 squares. Remember, it's easy to multiply that out, because you'll have your x by x, which gives us x squared, right? And then the x times y, you get your plus xy, the middle term minus xy, and your last will be your minus y squared. So in other words, the middle term is going to cancel out in your difference of 2 squares. So you've got x squared minus y squared, you get x minus y, x plus y, which is the same thing here. You've got your cos alpha, sine alpha, and you've got different signs. So in other words, your middle term is going to cancel out. So you'll be left with the cos alpha times cos alpha, which gives us cos squared alpha. Negative times a positive is a minus. Sine alpha times sine alpha is sine squared alpha. Right. I hope we are still together, comrades. So you've got your cos squared alpha plus 2 sine squared alpha, right? Plus sine squared alpha. Now, if you look at this, cos squared alpha plus sine squared alpha is 1, right? So I can have that 1 plus 2 sine alpha cos alpha. I've already used these two guys here. Now I need to remove that bracket by multiplying with that negative throughout. So I get minus cos squared alpha, okay? Negative times negative, you get a plus 2 sine alpha cos alpha minus your what you call your sine squared alpha. I'm just multiplying with that negative throughout. So this is all divided by 2. Now, there's something I explained earlier with your compound angle identities, that with cos, you've got 3 options. Cos 2 alpha is the same as cos squared alpha minus sine squared alpha, or 2 cos squared alpha minus 1, or 1 minus 2 sine squared alpha. And in this case, we've got cos squared alpha minus sine squared alpha, which gives us cos 2 alpha. This is an identity. All right. Now, very important. Here, now, I've got a 1 minus cos squared alpha. All right? What is 1 minus cos squared alpha equals to? Thank you very much. That is sine squared alpha. Where did you get that? From sine squared alpha plus cos squared alpha equals to 1. Now, if I make 1 minus cos squared alpha the subject, so watch, I've got 1 minus cos squared alpha. This gives us sine squared alpha. So that's where we get the 1 minus cos squared alpha being the same as sine squared alpha. So you've got now next sine squared alpha, and this is from your identity. Now, the 2 sine alpha cos alpha is the same as your sine 2 alpha, right? Plus, the 2 sine alpha cos alpha is the same as sine 2 alpha. And you've got that minus sine squared alpha, all divided by 2 cos 2 alpha. We're getting there. Right. Now, you've got the sine squared alpha minus the sine squared alpha. Those two are like terms. Okay? So sine squared alpha minus sine squared alpha gives us naught. Now, the sine 2 alpha plus the sine 2 alpha, those two are like terms, so we get 2 sine 2 alpha, all divided by 2 cos 2 alpha. Okay? Now, you know that you've got the 2 divided by 2, that gives us 1, right? And remember, there's an identity from your grade 11. Tan x is the same as sine x divided by cos x. So tan 2x is the same as sine 2x divided by cos 2x. Tan 3x will be the same as sine 3x divided by cos 3x. So in other words, if I've got tan mzegezege, that will be the same as sine mzegezege divided by cos mzegezege. So if you've got the tan changes to sine divided by cos. So this will give us the final answer of 2 tan 2 alpha. That is your final answer for your challenge question.
Most of them got it right, so impressive. Thank you so much, Mindsetters. And if you didn't get it right, thanks for trying it, and you know where you've made your mistakes, you can still correct them.
Thank you. Thank you to those who got it right. We're impressed. And to those who didn't get it right, we're not depressed, but push more. All right? So now, guys, we need to move on. Okay? Right. We look at your question 6, which is now you need to solve for theta, where you have from 0 to 180 degrees. So did I do this one, Abram? Okay? Now, so you've got cos 4 theta, cos 20, minus sine 4 theta, sine 20. Now, can you see that on my left-hand side, I'm repeating the same thing. Cos, minus sine, sine, right? And if you go back to your compound angle identities, if I've got cos of x plus y, this is, we said it's going to be cos, so it's cos x, cos y, change the sign, sine x, sine y, okay? Which looks similar to that. All right? So it's cos, cos, sine, sine. All right? So it can be reduced to cos of your first angle plus the second angle. And in this case, you've got your first angle as 4 theta and your second angle as 20, right? So this is in an expanded form, and then we can take it to the reduced form. All right, so you've got your cos, right? First angle, 4 theta. Change the sign. This is a plus. The second angle is 20 degrees, equals to negative 0.5. All right? Now, when you get to this point, right? Remember, I gave you a triangle this morning. Okay, today. You've got a 60 here. That's a root 3. That's 2 and 1, right? And a half cos of a half, right? So cos equals to something minus a half. So you say you need to get your key angle here. Your key angle or your reference angle. How do you get your reference angle? You say shift in your calculator. Okay, let's just do it. So you say second function cos of 0.5, and then you get that. That is 60, okay? So now our key angle is 60. Now we come back to the sign. All right? We're given cos. Saying cos equals to negative. So we're looking at the quadrant. Remember the all the trig ratios, positive first quadrant, sine positive second quadrant, tan in the third, and cos in the fourth quadrant. Now we're asking ourselves, we're saying selves, where is cos negative? So cos is positive here and there. So in other words, it is negative in the second quadrant and negative in the fourth quadrant. Now, how do I get an angle in the second quadrant? Right, thank you very much. So it's 180 degrees minus. So using the x-axis, so you've got 180 minus and then 180 plus on this one. So in other words, we have 4 theta plus 20 equals to 180 degrees minus our key angle, which is 60, right, plus. Now, we need to add in the period of cos, and cos is going to repeat itself for every after 360. So you've got your 360 degrees times k, where your k is an element of integers, all right? So that's the first bit. Now, what we need to do is to make theta the subject of the formula. Now, let's do some algebra. 4 theta will be equal to 180 minus 60. That gives us 100 minus, that's 120 minus 20, which is 100, plus 360 degrees times k. And simplifying that, we get 100 degrees divide by 4, you get 25 degrees plus. 360 divided, because we're dividing by 4 throughout, 360 divided by 4, you get 90 times k. Now, on that one. Now, this is where you stop when they say they're asking you to find the general solution. Now, the next part is when you have your 4 theta plus 20 degrees equals to, now, we're saying in the third quadrant, cos is also negative. So in the third quadrant, it's going to be 180 plus our key angle, which is 6 in this case. 180 plus 60, we get 240. Plus the period of cos as 360 times k. So we get 4 theta equals to 240 minus 20, that's 220, plus 360 times k. Then you make your theta the subject of the formula. Now let's just check your 220 divided by 4 is 55, right? So you've got your 55 plus the 90 degrees times k. Now, guys, you stop there when they're asking you to find the general solution. But now they're saying find the values of theta, and we're saying we're specifying there k is an element of integers, so you can sub in, but looking at your restriction, all right? So they're saying from 0 to 180 degrees. So in other words, you'll have your theta equals to, if I sub in a naught here, I get 25, right? If you sub in a 1, you get 90 plus 25, which is a 5, a 115. Or this side, because if you sub in a 2, you get 180 plus 25, which is more than the restricted part that they've given us. So your theta should be between 0 and 180. So we stop there. If you sub in a naught here, you get 55. Or if you sub in a 1, you get 5, 1, 4, 5. So you've got theta equals to 25, 115, 55, and 145. Any questions so far?
I think we can just go back to the very first question where mindsetters were struggling on how did we get minus sine 50 turning into minus cos 40.
Okay, the very first question. All right. Let's tell me when I'm there. This one. Is this the question they asked?
I think it should be that one where we said you were saying.
Oh, where we said, okay, sine 50 is equivalent to your cos
40.
40. All right, thank you. Now let's just look at that one. We said sine of 50 is the same as cos of 40, right? We did the correlations in grade 11. Now, how did we end up getting the sine 50 being the same as cos 40? Now remember, sine of 50 degrees is the same as sine of, now this is 90 degrees. For me to get 50, I'll have to subtract a 40 here, okay? Now, I hope you're all following, right? So, now the 90 minus, so I've got a 90 degrees minus an angle. So this is our first quadrant. How is sine in the first quadrant? It is positive. Now remember, with your co-ratios, if you've got a 90 degrees and a 270, your sine changes to cos and your cos changes to sine. So you'll have your cos of 40 degrees. Now, how do you confirm that? If you type in your cos 50, we get 0.64278, right? So now let's type in the sine 40, which gives us 0.627 and whatnot. Right now, if they add up to 90, because of time, guys, thank you very much for listening. I can see you. Peace.
Thanks for the great lesson. But a quick 2 words from you, for the mindsetters on this new term. How can you encourage them to begin this term?
All right, guys, please
especially those who didn't do right last term.
Right, guys, please practice your maths each and every day. Go on to websites where you've got past papers. You go to your Maths Excellence, you go to your GDE website, and just practice more. You can still make it.
So true, you can still make it. It's never too late, mindsetters. Make sure you fix your mistakes and practice even more. We're here for you as Mindset Learn Extra. Make sure that you go to our help desk app, which is available on Facebook. The link is on Facebook. But for today, we just want to end it there, saying, mindsetters, keep on believing in yourself and work extra harder because we believe in you. And have a good evening. Peace.
Thank you. We did it. So why can't you?